Welcome to today's video. Today we're going to be focusing on making conclusions using the law of syllogism. We're going to show that mastery in class by earning at least 10 out of 12 points on a short story. We'll talk more about that in class tomorrow. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet. We'll get you a fresh copy tomorrow. Now, tomorrow we're going to be focusing on how does it relate to TV, because you've seen this law plenty of times both in TV and books that you've read. You just don't realize it's geometry happening in real life. So, if we want to talk about what it is, it's a type of transitive reasoning. And if you remember the transitive property from algebra, if A equals B and B equals C, then A has to equal C. Well, it's going to be similar, but now we're going to use conditional statements. My first statement is going to say, if P, then Q, where P is my hypothesis and Q is my conclusion. My second statement needs to say, if Q, then R. And if you notice from here, we have Q's the same, except it moved from the hypothesis to the conclusion. From the conclusion to the hypothesis. As long as you have that, our conclusion for every law of syllogism is then going to become if P, then R. It's like those Q's cancel each other out. But they have to be exactly the same. It cannot be Q and negative Q. It cannot be Q and close to Q. They need to be the same. So, if we look at our first example, if it continues to rain, then the soccer field will become sloppy. If the soccer field becomes sloppy, the game will be canceled. Well, if I highlight what's the same, I have the soccer field will become sloppy. If we notice, it's if P then Q, if Q then R. Well, if this is my P, this becomes Q, this Q needs to be exactly the same, and they are, so then that is my R. Well now, if I look at the next sentence, it continues to rain. This is P, so my conclusion, if we go back to the conclusion, we have P, my conclusion is going to be R. So the game will be canceled. But we need to make sure everything's going to match. Now in this case, because we use the law of syllogism, it's valid. And we're just going to put syllogism down here. Oh, I spelled it wrong on the note sheet, and I apologize for that. It should be OGIS then. And we're going to learn two other laws to come, so that's why we want to make sure we know what law this is. So if we look at the second one, if a bank robber steals the money, then the police will track him down. If the police track him down, then the robber will get arrested. So remember, our first statement needs to be PQ. Our second statement needs to be QR in order for our third statement to become PR. And those three dots just mean therefore or the conclusion. It's just another way of writing it. So, if I look at this, I have P. I'm going to highlight my Q so that we can make sure that they're the same. If I look, the police will track him down becomes Q. The police will track him down is still Q. And the robber will be arrested is R. Now, if I look at that second line, a bank robber got arrested. Well, if I look back to my symbols, this is actually R. We can't start with R for our conclusion. We have to start with P. So in this case, it is an invalid, and then conclusion is nothing can be determined. We don't know why the bank robber got arrested. Was it because he stole money? Was it because he stole a car? Was it because he broke into a house? We don't know. So it is an invalid conclusion because we started with R when we need to start with P. So, our third one. If Nate is reading, then he is reading a magazine. If Nate is bored, then he's listening to music. So let's start at the beginning. We have P, this should be our Q's. And if I look, Q is he's reading a magazine. Well, Nate's bored. That's not Q. That has nothing to do with Q. So, in this case, it is invalid. Our conclusion, again, is nothing can be determined. And the big reason, they don't match. If they do not match, you cannot have a conclusion using the law of syllogism. So make sure those Q's match. And that's why I highlight them to remind myself. If those two highlights don't match already, we know it's an invalid conclusion. Our last example. If a number is a whole number, then it's an integer. If a number is an integer, then it's a rational number. Again, let's label it. So if a number is a whole number, that is P. I'm going to highlight my two inside parts. Called the first one Q. It's an integer. Well, if I look, this bottom highlight is also a number as an integer, so that's Q. Making the rational number R. So now we have, for our first sentence, we have PQ. For our second sentence, we have QR. So now we need PR. Well, if I look, the number is 18. You have to ask yourself, is 18 a whole number? Well, a whole number is any number from 0 on up. So this is P. 18 is a whole number, so that is P. The conclusion then becomes 18 is also a rational number based on the law of syllogism. It is a valid statement because we could come up with a conclusion. The biggest thing to keep in mind is those inside pieces need to match. Once they match, we need to make sure that our second statement goes back to P. Our conclusion can be R. But if our second statement does not match P, we cannot make a conclusion. And it's okay to have an invalid conclusion. There are going to be times that that happens. So we need to just make sure we're paying attention to which order our original conditional statements are in. Try the bottom. It's just a matter of putting it into symbolic notation as a review. We'll go over that in class tomorrow. Bring your notes and any questions you have to class then. I look forward to seeing you.